Morning everybody, welcome to another week of lockdown. Today what we're going to look at is trig identities. We're going to try and find some new trig identities from the one which is in front of us here, sine squared theta plus cos squared theta is equal or equivalent to 1. So we're going to find two new trig identities using this, and then after that I'm going to go through basically a list of tools for you to use today. They're not new tools, they're tools that you know already. But I'm just going to make a particular point about them, and then after that you guys got some exercises to do, and these exercises which you're going to do today are probably, well, they can be some of the most infuriating exercises you can do in A-level maths in some ways, because it's really difficult for me to say this is how you do this. It's very much a case of I have to give you the tools to use it and then say this is problem solving at its best. You know, some of these tools will unlock the puzzle to getting to the end of this, and so you have to approach this with real resilience, but also just an acceptance that it might be quite tricky, and take real pleasure from the process, not just getting to the end. So I'll show you an example of what I mean by that in a moment, but first of all let's just try and find two new trig identities which we need for today. So I've written down sine squared plus cos squared is equivalent to 1. What I'd like you guys to do is, first of all, can you divide this whole thing by sine squared, see what you get, and then afterwards can you start again and then divide everything by cos squared and see what you get. Just pause the video, come back to me when you've done that. And so hopefully when you divide it by sine squared, you've got sine squared theta divided by sine squared theta is 1, plus cos squared theta over sine squared theta is equivalent to 1 over sine squared theta. And similarly with this one, hopefully you've got sine squared theta over cos squared theta plus cos squared over cos squared is 1 is equivalent to 1 over cos squared theta. And I'm hoping that a lot of you have gone one step further. So this top one here, let's call you number 1. If you think about what you've got in number 1, you've got cos squared over sine squared, which is cos over sine all squared. Cos over sine is cot. So that first one is actually equal to 1 plus cot squared theta is equivalent to 1 over sine. 1 over sine is cosec, so 1 over sine squared is cosec squared. And if we look at number 2, we can do something similar. Sine over cos is tan, so sine squared over cos squared is tan squared theta, plus 1 is equivalent to 1 over cos squared. 1 over cos is 1 over sec, so 1 over cos squared is sec squared. And these are two formulas that you guys really need to know, sorry, two identities that you really need to know. They're very useful, and I can't remember if they're in the formula sheet or not, but you really need to know what they are, because you need to be able to spot them. It's no good just thinking, oh, it's in the formula sheet, I'll use it when I need it. You need to be able to spot them when they turn up. And that won't necessarily mean that you're going to the formula sheet searching for them. If, like me, you have a memory like a sieve, I don't think I've ever committed these two to memory. I don't think I even did it for my A-level actually. That always stuck in my memory fine, and so whenever I come across a trig question, I still do this now even sometimes when I'm teaching a class, I literally write that down and then quickly divide by sine and cos squared to get these. I don't use that in the exam, I just write this in the exam. I write sine squared plus cos squared like that, and then just quickly divide through by s squared or c squared to find out which one's which. So yeah, if you have a memory like a sieve, feel free to do it this way, but in the first instance try and commit it to your memory because it will be very useful. So there are two things that we need to know for today, and there's a few other things we need to know as well. The third thing, I'm going to write this down again even though it's at the top of the page. We've got, and I'm going to use the shorthand, sine squared plus cos squared is equivalent to 1. Now that's useful, But also today, I'm not sure if it necessarily will be useful today, but it can be useful with these sorts of questions, is recognising that 1 is sine squared plus cos squared. Now you might be thinking, what on earth have you done that for? Sometimes with these sorts of questions, you'll be trying to get from point A to point B. You'll have some sine squares and cos squares. You might have a 1 somewhere, and you might be thinking, crap, I don't need a 1, I need some sines and cos. Well, one of the ways that you can go from a 1 to something different is by doing the reverse of this process, essentially. So don't be afraid to do reverses. There's another reverse process coming up in a second. So another thing which you guys need to remember is tan is sine over cos, and similarly, sine over cos is tan. Think about these things both ways. Difference of two squares. These come up quite often with this sort of thing. Difference of two squares is something you really need to get used to if you're thinking about doing step and things like that in the future. So difference of two squares. So for instance, if I had sine squared theta minus cos squared theta, that's equal to sine theta plus cos theta sine theta minus cos theta. What you'll end up with is something like this in the numerator, and you'll end up with one of these in the denominator. And so if you split this into the difference of two squares, then something will cancel. You need to look out for quadratics. And these are normally quite easy to spot, but for instance you might have something like sine squared theta plus 4 sine theta, oops, that's meant to be a plus 3, and obviously that's equal to sine theta plus 3 sine theta plus 1. That's right, isn't it? Yes. So again, if you had something like this in the numerator, you might have one of these in the denominator, so if you factorise the top you'll get some cancelling. And the last one is actually the simplest one, because it's the thing that you've known for the longest. However, it's the thing which ends up causing people more difficulty than probably expected. So for instance, if I was asked to show, what we're trying to do, we're trying to do fractions. So basically we're doing fractions in reverse. So we know how to add fractions together, but very often people don't think about undoing the addition of fractions. So for instance, if I wanted to show that cos theta minus cos cubed theta over cos theta is equivalent to sine squared theta. Now, there's one very quick way of doing this, which doesn't require separating it out into fractions. I'm not going to do that method. If you can see that method by factorising, then feel free. The method I wanted to show you was, okay, if I want to show that this is equivalent to that, what I can do is I can work on this left-hand side, and I can say that cos theta minus cos cubed theta over cos theta is this. So all I've done is I've separated this back out into its original fractions. It was cos theta over cos theta plus minus cos cubed theta over cos theta. That's how you add fractions together. You make the denominators the same, and then you write the sum of the top bits over the denominator. So if I've separated these out, then that's equivalent to, well, cos theta over cos theta is 1, cos cubed over cos theta is cos squared, and 1 minus cos squared is actually just sine squared. Okay, so before you do any exercises today, what I thought we'd do is 3 examples together, and to hopefully get you in the right sort of frame of mind to have a crack at some of these. So I'm going to give you a question, you guys are going to have a quick go at it, and then I'll go through the answer. So let's try the following. Can you prove that? So number 1 is going to be tan squared theta plus cot squared theta is equivalent to sec squared theta plus cosec theta squared take away 2. Okay, so you can start with the left-hand side or the right-hand side, it's up to you. One thing you can't do is you can't divide through by things. You have to work on either this side or this side and show that it is the same as the other one. So whichever way you start, for example, I would probably start with the left-hand side with this one, write LHS for left-hand side, and then start manipulating that until you get it equal to the right-hand side. Have a quick go at that, and then come back to the video when you think you've had a good crack at it, or if you want a hint. Okay. So the first line of working, you've got tan squared theta plus cot squared theta, and using our new identities we found out today, tan squared is sec squared, take away 1, and cot squared is cosec, take away 1. I'll pause then for a second in case you want to keep going with this. And hopefully you can see from there that we've got sec squared, we've got a cosec, we've got 2 minus 1s. So that's sec squared theta plus cosec squared theta take away 2. So a relatively straightforward one. Let's try another example. So sec squared theta is equivalent to cosec theta over cosec minus sine theta. Okay, so again, have a quick go at this one, see how you can get on with it. Just before you pause the video, I would suggest you start with the side which has more stuff on it in general. So I would start with the right hand side this time and try and show that it's equal to the left hand side. Okay, pause the video, have a go at that one please. Okay, so this is quite a tricky one, I think. It's always good to think about what you have in front of you, thinking about what these are in terms of sine, but it's also good to think about where you need to try and get to. This is sec squared theta, and sec squared theta is 1 over cos squared. So basically this whole bit here needs to be 1 over cos squared, and if this has to be 1 over cos squared, that must mean this top bit needs to end up being 1, and this bottom bit has to be cos squared. So you've got 2 pieces of information there. This top has to be 1, the bottom bit has to be cos squared. So the way to go about this sort of thing is by saying to yourself, okay, well, can I make one of those things happen? So I'm going to make one of those things happen, maybe the other thing will happen too. So let's just think about this for a sec. Cosec is 1 over sine theta, and that's all over. I've lost my protractor. Cosec theta again is 1 over sine theta, and we've got a minus sine theta there. So at the moment this right hand side has got, so I should have said right hand side, didn't I? I should have said right hand side and then carried on like I did here. Never mind. So all of this stuff on the right hand side is in terms of sine theta now. I know I need to get the top bit to be equal to 1. If I've got 1 over sine theta here, what I could do is I could times the top by sine theta, because that would be sine theta over sine theta. So if I times the top by sine theta, that becomes sine theta over sine theta, which is just 1. If I times the bottom by sine theta, and remember I have to times the whole of it by sine theta because it would be like expanding over a set of brackets. That would be sine theta over sine theta, which is 1, and this would be minus sine squared theta. Ah, that's good news. The top is 1, and the bottom 1 minus sine squared, or 1 minus sine squared is cos squared using, using our sine squared plus cos squared equals 1 identity. And 1 over cos squared is just 1 over sec squared. Okay, so I hope that one went well. A bit of a trickier one, that one, but again, it's about trying to see about what you need to get to. So let's have a go at one last one before I set you off on some exercises. Hello, Sebastian. So we've got 1 minus cosine theta, 1 plus sec theta, and that's equivalent to sine theta tan theta. Okay, so what I want you guys to do now is have a go at seeing if you can work out how to do this one. The left hand side has more stuff on than the right, so I suggest you start with the left hand side. I also suggest you think about what this looks like on the right, because that might be some assistance. So have a go at that and come back to the video when you think you're done. Okay, so just to get you going with this one, if you do expand the left hand side out, you're going to get to this. From here, start thinking about what you're going to need at the end. At the end, this is going to be sine squared over cos, tan sine over cos. So this is going to be sine squared over cos. So you need to think about how you're going to inject a denominator into this, the denominator of cos theta, and think about how to bring it back together. Keep going with this one. I'll pause the video again and write some more stuff. So hopefully you've managed to just simplify this a little bit and get it in terms of cos thetas. From this point, have a think about getting this in terms of one fraction, and then seeing if you can make that into what we need at the end. I'll pause the video again. Okay, so just making that into one fraction. If I write them both over cos theta, I have to times the second thing by cos theta, which goes to cos squared theta, and 1 minus cos squared is sine squared. And from here, hopefully you can see how it's going to finish. This is the same as sine theta times sine theta over cos theta, which is equivalent to sine theta tan theta. Okay, so there's 3 different examples. They haven't used necessarily all of the tools I gave you earlier, but please keep those in mind. The key to this is by saying to yourself, start with the side which seems to have more stuff on it, and think about what the right hand side or the left hand side, what the side you're trying to get to, think about what that really is in terms of probably sines and cosines, and working in terms of sines and cosines seems to quite often be one of the best ways of dealing with these things. Okay, so there's quite a lot of different bits to exercise 6D, but actually what I want you guys to do today is just focus on question 6. There's 8 questions there, and that should be more than enough for today, because either you'll get them very quickly and you'll think, why didn't he set me more work, but then you'll speak to somebody else and it took them 2 hours or something stupid. It's one of these things where you either see it or you don't. Don't feel bad about it if you aren't getting on very well with it. This is one of these things that you just have to spend time doing it to get good at it. So please get stuck in, please be resilient, and try and enjoy it, because it really is problem solving at its best. Okay, I'll speak to you guys again tomorrow. Bye bye.